Hello everyone, I am Abhishek Singh. My project title is Network Attacks Detection and Mitigation. I have had the privilege of being mentored by Professor Colin Paul and Dr. Rajesh Paul sir. Here is what I will be covering in this presentation. We will start from motivation, then move on to the problem statement, then the solution, how we approach these challenges. Then we will define the tools and methods we used for this project, the result and analysis part, and the conclusion, our key takeaway and findings, the future work, and finally the references. So let's begin with our motivation. Let's talk about why our project is so important. Think about our mobile phone. It's always with us. Whether we are at work or just relaxing, we use it to check emails, visit websites, and do all sorts of things. Over time, it collects a lot of our personal and work related information, and maybe we send some sensitive information to trusted server and so. But here is the catch: bad people like hackers may try to steal this information. They may use some sneaky tricks like fake app, tricky emails, maybe bad website, links to get your data. They might want to steal your secrets or just make money from your information. And guess what? There have been some big attack on mobile phone recently, like the Pegasus software spyware and the FluBot malware in 2022. These are just example of the kind of threats mobile devices face today. So let's look at the problem we are trying to solve. So we aim to detect each and every type of network attack which is possible on mobile user. So first and foremost, we are focusing on a particular type of attack that is called port scan attack. This is when someone tries to enter into our device by checking which ports are open. So our goal is to stop them then and there. Now, why is this a problem? Well, these days we do almost everything on our mobile, from email to business stuff. With more mobile activity, there are more bad actors trying to mess things up. The old ways of stopping these bad actors, like using signature based approach, don't work so well anymore, especially against new type of attack. So we are trying a different approach called anomaly detection. It's like looking for unusual pattern instead of just known bad stuff. So this way we can catch both the usual and the brand new attacks also. Let's see how we are tackling this. We are using machine learning algorithms, which is like training a model to recognize things. So first we give it lot of example of network data. So it learns what normal and what a port scan attack. Once the model is smart enough, we put it inside your mobile phone. To keep an eye on the network, we create a local VPN service to capture the real network packet. It watches all the network traffic and catches any suspicious packet. When it sees something fishy, it look at the data closely and check it if it is a port scan attack or not. So for the data set used, we selected the CIC IDS 2017 dataset because of its comprehensive coverage of various network attack. This dataset include multiple attack types such as port scan attack, DOS attack, bot attack, web attack, and many more, and making it ideal for this project. For instance, the graph illustrates that the abundance of data for port scan attack consisting of approximately, we can see, 1 lakh 60,000 malicious packets and 1 lakh 20,000 are the benign packet. So we'll use this CICIDS 2017 dataset to train our model. Um, so here is the thing. Algorithm, we employed the random forest regressor algorithm to pinpoint crucial feature for port scan detection. Initial features. Our analysis begin with 85 features, in which only 4 features exhibit the high significance in detecting port scan attacks. We are not considering these 8 common features such as flow ID, IP address, port, because attacker can easily evade this, and they can just manipulate these common features to evade detection of port scan attack. So we are not including these 8 common features. Depending solely on port number can be also misleading, because it may operate on dynamically. So moving on to the experimental setup, we focused on capturing network packets effectively. To achieve this, we developed an Android application called PCAP Receiver. This application has the unique capability to capture its own live network traffic by simulating a local virtual private network environment. Essentially, it creates a controlled private network environment within the device itself. Importantly, this simulation is entirely local to the device and does not involve sending data to a remote location. So as we can see, on clicking the start capture button, the app is able to collect various network packets, some of which are UDP type and some of are TCP type. These packets represent different type of data transmission on the network, and they are all captured for further analysis. The captured network package is saved in the common PCAP format, which is a standard format for storing network traffic data. Later on, we can convert this PCAP file into a more analyzable CSV format using Python. So this setup allows us to collect real-time network traffic data efficiently for analysis. For our demonstration, we are using a well-known application called Nmap to perform a port scan attack. As depicted on the slide, we are directing this attack toward our target device where our app is installed. The purpose is to illustrate how our system capture packet sent by Nmap during the attack. After capturing these packets, our module extract relevant feature from the network data. These features are then sent to our pre-trained ML model, which evaluate whether a port scan attack has been carried out or not. In this slide, you can observe that we have extracted our crucial feature for network packet analysis. These features are sent to our ML model. After evaluating 7 ML model, we selected the most effective one, which we will see in later slide. So on the left, we can see that the model's output when no attack is detected, indicating as a safe network. And on the right side, when we launch an attack using the Nmap tool, the model swiftly identifies it and warns us as a malicious network found. Disconnect quickly message. Now in this section, we delve into the outcome of our experimentation. We applied 7 distinct ML model to the port scan file, repeating the process 10 times. This approach allows us to assess the effectiveness and performance of various ML techniques across different attack scenarios. Upon reviewing the result, a noteworthy observation emerges that the random forest, KNN, ID3, QDA, and ADA boost algorithm have all demonstrated a detection success rate of over 90% when it comes to identifying the port scan attack. Among these 7 algorithms, ID3 and random forest and this KNN uh, stand out as the most successful in all aspects. In this visual representation, we present the box and whisker plot of F1 score achieved by various ML models, notably the random forest ID3 and nearest neighbor ML model have achieved a perfect F1 score of 1 when it comes to detecting port scan attack. Following closely, we have the AdaBoost and QDA models showcasing strong performance in this regard. In this bar plot, we are comparing how well different ML model algorithms detect port scan attack. We are looking at two important factors: accuracy and precision. So random forest ID3 and nearest neighbor perform exceptionally well, achieving perfect score in both accuracy and precision. Naive Bayes and multi-layer perceptron shows decent performance but not outstanding. QDA and AdaBoost stands out as a strong performer with high accuracy and precision. These results basically help us to select the most effective algorithm for detecting port scan attack. In the next slide, we can see the bar plot, and we are focusing on two crucial metrics for here for evaluating the performance of ML model in detecting port scan attack is recall and F1 score. So here again, random forest ID3 and nearest neighbor demonstrate exceptionally performance with perfect score in both recall and F1 score. New bias and multilayer perceptron shows decent performance but lags behind in both recall and F1 score. QDA, that is quadratic discriminant analysis, and AdaBoost continues to stand out as a strong performer, achieving high scores in both recall and F1 score. In the next slide, we can see the time taken by various ML model for training and testing. We can see that the naive bias is the quickest, requiring only a fraction of second for both training and testing. QDA follows with a short duration for both phases. Random forest and ID3 perform efficiently, taking less than a second for training and testing. AdaBoost, MLP, and nearest neighbor exhibit longer duration, with AdaBoost taking the most time. So these time measurements are also crucial for evaluating algorithm efficiency and resource consumption when implementing them for the real-time network attack detection. Now the data is strongly support the if we can see the overall performance, then we can see that the random forest algorithm for our purpose, it consistently achieve perfect accuracy and precision, indicating its excellent ability to identify port scan attack accurately. It maintains an impressive balance between precision and recall, making it a relatable choice. In terms of efficiency, it stands out with shorter training and testing time compared to other method. So we have chosen the random forest algorithm as the best fit for our network attack detection system, basically for port scan attack. Now this project basically focused on creating a machine learning model to spot port scan attack in real time network traffic. We tested the model with 7 different ML models. The result highlighted random forest ID3 and nearest neighbor as the most effective for our dataset. And this work underscore the significance and efficiency of ML techniques in identifying network attack. Now in the future we plan to test the model with more diverse and complex dataset to ensure it can detect various network attack accurately. We also want to we also thinking of developing a multi-layered machine learning system for improved performance for higher reliability, so that false positive can be lesser and lesser. We now after that we are thinking of integrating the model into So we have integrated the model into mobile app to make it more practical and user friendly, and also making it after exploring new methods for identifying and preventing emerging network attack, incorporating the advanced feature engineering techniques. Here are some references we have taken into account. Thank you for listening.